Imagine you wake up one morning and the sky looks different. The stars are moving, slowly at first, then faster. Scientists around the world are picking up something on their telescopes, something massive, something dark. A black hole is heading straight for our solar system, and nobody can stop it. So what actually happens next? What happens to Jupiter, to the moon, to us? Today we're going to find out, step by step, exactly what a black hole does when it swallows an entire solar system. And trust me, it's going to get weird. Before we get to the scary part, we need to understand what we're actually dealing with. A black hole isn't a hole. Not really, it's an object. An incredibly dense, incredibly massive object, with gravity so strong that nothing can escape it. Not rocks, not gas, not even light. That's why it looks black. Because even light, the fastest thing in the universe, gets pulled in and never comes back out. Here's a way to think about it. Imagine holding a bowling ball in the middle of a stretched-out bed sheet. The sheet sinks in the middle, right? Now imagine something 1,000,000 times heavier than that bowling ball. The sheet doesn't just sink, it tears right through. That's what a black hole does to space itself. Most black holes form when a massive star, way bigger than our sun, runs out of fuel and collapses under its own weight. All that mass crushes down into a tiny point, and the gravity around it becomes so powerful. Nothing gets out. The edge of a black hole, the point of no return, is called the event horizon. Cross that line and you're not coming back. Ever. Now here's the wild part. The black hole heading toward us? It's what scientists call a stellar mass black hole. About 20 times the mass of our sun. Not the biggest kind out there, but more than enough to tear our entire solar system apart. It's still years away, but it's coming. And the effects? They've already started. The first thing to understand is that a black hole doesn't just show up and swallow everything at once. It's not like a vacuum cleaner, it's more like a tide, a gravitational tide, that pulls harder and harder the closer it gets. And the first victims? The outer planets. Neptune goes first. Neptune is so far from the sun that it's already cold and dark out there. -200 degrees, but as the black hole approaches, Neptune's orbit starts to wobble. The planet gets pulled off course. Slowly at first, then all at once. Neptune gets stretched. Scientists call this spaghettification. Yes, that's a real word. The side of the planet closest to the black hole gets pulled harder than the far side. The planet stretches like taffy, and eventually, it's torn apart entirely. Then, Uranus. Same story. The rings scatter first, then the planet itself unravels. Saturn is next, and this one hurts because Saturn's rings, billions of chunks of ice and rock, they get pulled away before the planet does. Imagine watching those beautiful rings just dissolve into the dark. Then Jupiter, the biggest planet in our solar system, a planet so large that over 1,300 Earths could fit inside it. Jupiter fights back harder than the others. Its gravity is immense. But it's not enough. The black hole is stronger. Jupiter stretches, tears, and disappears. By this point, the sky from Earth looks nothing like it used to. Jupiter was always one of the brightest objects we could see. Now it's gone. The nights are darker, and something enormous is getting closer. The asteroid belt between Mars and Jupiter, those millions of rocks scatter like dust. Some fly outward into space, some get pulled toward the black hole, some head toward us. Mars is next, the red planet. Stripped of what little atmosphere it has left, pulled apart, gone. And now, there's nothing between us and it. This is where things get intense. Long before the black hole actually reaches Earth, we start feeling it. The tides go first. The moon controls our ocean tides, but now the black hole's gravity is interfering. The oceans start behaving strangely. Tides that used to rise a few feet now rise dozens of feet. Coastal cities flood. The water doesn't go back down. The moon itself starts to wobble in its orbit. Then the atmosphere, the gases that make up our air, oxygen, nitrogen, they start to get pulled upward. Not all at once, but slowly, the sky gets thinner. Thinner air means less protection from radiation. The temperature starts to swing wildly. Meanwhile, the ground is shifting. The gravitational pull isn't even across the whole Earth. One side is closer to the black hole than the other. That difference causes the planet's crust to crack. Earthquakes everywhere. Volcanoes waking up. The planet is being stressed like a piece of metal, being bent back and forth. Then, the moon goes. pulled from Earth's orbit and dragged toward the black hole. The night sky, which always had that familiar glowing circle, goes dark. And without the moon's stabilizing effect, Earth's tilt starts to go haywire. Seasons stop making sense. Weather becomes extreme beyond anything we've ever seen. And then, it's our turn. The black hole is close now. Close enough that the difference in gravity between one side of Earth and the other is enormous. The planet begins to stretch, the oceans pour off into space, the atmosphere tears away in ribbons of gas. The Earth, our home, begins to spaghettify. It doesn't explode, it doesn't burn, it stretches, like a long thin noodle being pulled towards something infinite and dark, and then it crosses the event horizon, and it's gone. Okay, take a breath. That was a lot. But here's the thing about black holes that most people don't know, and this is the part that actually blows scientists' minds. Black holes aren't just destroyers, they might be some of the most important things in the universe. At the center of almost every large galaxy, including our own Milky Way, there's a supermassive black hole. Ours is called Sagittarius A. It's 4 million times the mass of our Sun, and it sits right at the heart of everything. Scientists now think that black holes actually help galaxies form. Their gravity pulls gas and dust together. That material becomes new stars, new planets, maybe new solar systems just like ours. So, in a strange way, black holes don't just end things. They might also begin things. Everything the black hole swallowed, Neptune, Jupiter, Earth, the Moon, that material doesn't just disappear, it adds to the black hole. And billions of years from now, some of that matter might be released in ways we don't fully understand yet, seeding new stars across the universe. Carl Sagan once said, "We are made of star stuff." The atoms in our bodies came from ancient stars that exploded billions of years ago. Maybe one day, somewhere out there, something new is made from us too. So that's what would happen if a black hole swallowed our solar system. The good news? There's no black hole heading toward us right now. Our solar system is safe, for at least another 5 billion years, but somewhere out there in the universe, this is actually happening. To other stars, other planets, maybe other worlds just like ours. Space is wild, and we're just getting started. If you want to keep exploring, subscribe to Smart Kids Facts. Every week we take the biggest questions in the universe and break them down so anyone can understand them. And let me know in the comments, which planet do you think would put up the biggest fight against the black hole? I say Jupiter, but I want to hear yours. See you in the next one.